So thank you everyone for joining this webinar today, our Retrofit Talks with Buckley Gray Yeoman, who have been a fantastic partner in the Retrofit 24 programme, which is all about the reuse agenda for our commercial, cultural and civic buildings. So I'm Laura Broderick, I'm part of the Building Centre team, and we'll just be hosting and introducing very briefly today and handing over to Rachel Owens, who's the Head of Sustainability at Buckley Gray Yeoman, to introduce the panel that she's brought together to tell you all about Giltspur Street, which is a project currently on site in the City of London. And I believe very little's been revealed so far about it. I think it's been presented at one of the key conference. So this is a great chance for you to learn about some of the innovations in this fantastic retrofit process. So the way the webinar will run is we'll hand over to Rachel shortly. She will introduce her fellow speakers, and then there'll be about half an hour in total of presentation collectively as a panel. And once they've finished their presentation, you as our audience can put your questions to them. So yeah, that's it from me. I'll kind of be in touch at the end just to tell you more about the rest of the Retrofit 24 events. But for now, I'll hand over to Rachel to introduce the speakers today. So thanks everyone. Bye.
Thanks so much, Laura. I'm Rachel Owens, Head of Sustainability at Buckley Gray Yeoman, and I'm joined here by my colleague Charlie Damerel, who's the project architect on the Giltspur Street project. Also with us is Daniel Bassett from ElliottWood, the structural engineers, and Rachel Broughton from Simten, they're our client. So we're going to start sharing now, and I'll hand you straight over to Charlie.
Thank you, Rachel. So 20 Giltspur Street, it's located in the City of London, just off Newgate. As you can see, it's just opposite the Old Bailey. And notably, as you can see from the right-hand side of the screen, within the environs of St Paul's Cathedral. It is also located on the original outline of the London Wall. And in fact, there's a portion of the existing, an excellent portion on display in the basement of the building. So, existing building. So it was constructed around about 2003. The original building was constructed as part of the Bank of America Commercial Services trading for the UK. They now vacated the building. It is a fully steel-framed building arranged over 4 floors, plus ground and a basement, and a plant area at roof level. The primary facades that are visible from the street are clad in Portland stone, with the rear facades clad in a terracotta-coloured brick precast panel, and then all 4 facades are infilled with glazed curtain walling. Internally, its appearance and arrangement conforms to a typical building of its era. It has a relatively diminutive entrance and reception, has a regular grid, dense occupation for desks and workstations, suspended ceiling with associated concealed services, and notably on some floors, very high floor-to-ceiling heights that was the norm for trading floors of the era. So, based on that, the brief of the project was to revive, refurbish, and reposition the now vacant building for speculative rental. This included an internal fit-out, new WC provision, complete replacement of the services, and new external space. And then another portion of the brief was included was a desire to see if there was any ability to increase the NIA of the area of the building wherever possible. So, based on that brief, the location of the building brings with it a certain number of constraints. So the plan itself, as you can see on the left-hand side with the red line, is essentially fully developed. It extends all the way to Giltspur Street, to the Service Road to the north, Minerva Walk to the south, and then the Cardinal Courtyard on the east. So while this may be all reorganised internally, there's not a lot of scope to be able to add area to the outside of the building. The section is the same. As you can see, the dotted red line is the St Paul's viewing corridor, so there is not really much scope to increase the height of the building. But also in the basement, we have the scheduled monuments, so we can't go any below that. And also, given its location, there's a lot of archaeological potential in the area, so we don't want to go any further down than that. Coupled with that, there's also the former post office railway directly down the building. So structurally, there's a fair number of limited ways we can adjust the building. But as you can also see in this section, you can see ground floor, the first floor and the second floor are all much higher than, say, the other floor. You can see a third and fourth, which gives us an opportunity of potentially, could there be an area to be inserted where there's an extra space. So taking those parameters, we're able to craft a list of constraints and opportunities. There, it should be said that some of the constraints are also opportunities. So the constraints side, we include St Paul's viewing corridor, the scheduled monument, the aforementioned constrained site, proximity to listed buildings, proximity to residential buildings, including the St Bart's Hospital to the north. But all these provide potential opportunities. St Paul's sightlines also means that no other building is higher than 20 Giltspur, allowing great views off St Paul's. The scheduled monument becomes a feature of the building. If we want extra terraces on top of the building, because of the fact that everyone's lower, because the viewing corridor, we have very, very good views across London. It being an island site means it's got 4 independent facades. We've got less concerns over party wall and having to deal with adjacent buildings. With the higher floors, that means we can do a bit more manipulation with the entrance, potentially make a much more large focal entrance. And then because it's got the courtyard at the rear, there's an opportunity to create more flow through the building to bring the courtyard more into public realm. As well as seeing if there's a way of adding more commercial space. So, key moves. So here you can see the existing building. The existing building had a ground floor with a constrained entrance on the corner. We've got 4 levels of accommodation, the uppermost being set back, and a plant area on the top. On the right, you can see how we've adapted the building. We've reconfigured the facade to allow for the potential extra floor to come in because of those higher floor levels. We've enhanced the enhanced double height entrance. We've got a lightweight extensions at the rear where we were able to get a little bit of area in for the external envelope. We extended out the upper floor, and then we consolidated the plant at the top to allow for more accommodation at the top level. Internally, I think it's demonstrated by the plans. We've got on the left shows the ground floor, showing how we've massively expanded the reception area and included in the 2 darker orange areas the flexible retail units. And by adapting the entrance has now been recessed so that the main entrance is now on the sort of middle south of the building. It means that when you arrive at the building, you arrive right into the heart of the building. You're right at the heart of the reception, you're right next to the flexible retail units, and the scheduled monument is the right part of it. So nothing is put to one side. The whole building is now a sort of holistic approach to how the site works. It also allows direct connection with the courtyard through full glazing on the east side. We've also relocated all the bicycle stores, the EOT areas, the various different elements of plant to the north side of the building, where there's a service road which assists servicing, but it also means that it's the less prominent facade, so all the more facades can be much more emphasised. On the right, you can see the typical floor plan. This is actually the 5th floor. You can see the terrace on the bottom left-hand corner. We have completely consolidated the core. We've refurbished and upgraded the WC provision with new superloos. We have new lifts. And then specifically on the east side, you can see 2 prominent protrusions. Those are the meeting pods we've added from 1st floor and above, so they cantilever out from the building. And then we've added little bits of cantilevering in the infill on the east and north sides of the building, just to sort of, again, to increase that bit of commercial area that's available. And then this leads us with what we have with the proposed section. So this is where the big impact we've done thanks to those high trading floors we have. Well, we've effectively taken what was level 1 and level 2 and lifted them up to become new level 2 and level 3, and inserted a new first lightweight floor at 1st floor, which effectively allowed us to add the equivalent of roughly an additional floor of area into the building without necessarily massively impacting the envelope. How that manifested on the front facade? We have maintained the Portland stone facade on the prominent areas. We have a new GRC clad loggia at the upper level, as well as new planters integrated into the main portion of the facade at prominent locations. On the rear, where we have the meeting room protrusions and the various other extensions, we have maintained the same terracotta brick GRC panels and the curtain walling, as well as sort of maintaining the Portland stone elements that were there originally. One of the other large parts of the brief was also to enhance biodiversity and access to green space. So part of that has been at ground floor. As mentioned before, there is a courtyard between the original buildings. Now, the big advance that actually came to this was that there used to be a link bridge between this building and its neighbouring building. So taking those link bridges out has obviously massively contributed to the amount of natural light the courtyard will get, as some better growing outcomes. So there's a whole new programme of new planting, as well as new planters and street furniture in that courtyard. What we intend to do is make sure we maintain the existing hard landscaping, because it works. There's no need to change something which works perfectly well. We've added where we can. We've added corner planters, which are fully integrated irrigation, and they're attached to the sides of the meeting pods as well as the main front facade. And then we've also added new terraces in level 5 and 6. To capture those uses and pools, and also across West London. The west side terrace up 6th floor is a communal terrace where there's an integrated bar, which, as you can see from this image, is fully planted, but it also allows for the occupants of the building to have events, as well as use it for general rest and recreation. So, operational energy. While we are not actually, we have designed the cafe, although the cafe will not be installed, but it, as mentioned before, all services have been replaced so that the building is now fully electric. We have upgraded the external fabric of the building to enhance its thermal qualities, but it's based on a principle of having low energy chilled ceilings, efficient daylight, and present sensors with efficient lighting. And we've also optimised the ventilation control using a mixed mode system, where we have open all windows and a traffic light system, which allows the occupants to know when it's best to open the windows or just have the main ventilation strategy. However, we will not necessarily, apart from the mixed mode ventilation, we're not be installing the Cat A on day 1, which is being done to embodied carbon. One of the big savings we can make sure we're doing. So, because it's going to be delivered showing core and no Cat A, although it's been fully designed, it means that we can save all potential changes a potential tenant might make to a Cat A scheme. The same goes for raised access floor. We're not installing a raised access floor, and encouraging the tenant to put in a reused or recycled raised access floor, and as well as the ceilings, we're not boarding the ceilings unless it's required for fire. As mentioned, we also kept the external paving, and then we're keeping the facade and maintaining the facade as much as we possibly can. On that facade, this is where we can maintain the verticals as much as where we can, which is most of the verticals. But obviously, with the change in the floor levels, we've had to take the spandrels out. We did consider whether we could actually move the spandrels, but the way the original construction didn't allow for that, so we've had to put in new lightweight GRC Portland stone clad spandrels. We are looking at investigating opportunities where we can reuse the stone from from those spandrels. And then just a quick mention on how we got to the point of adding the extra floor. So on the left-hand side, you can see the original configuration of the building, where there's the tall floors at ground, first and second. The original idea was to take the first and second floor out altogether and install cross-laminated timber, new cross-laminated timber floors at first, what would become new first, second, and third floors. However, once we started talking to the enabling works contractor, they actually suggested an alternative where we actually maintain the existing level 1 and level 2 and jack it up so that it becomes the new 2 and 3, and then insert a new lightweight steel deck at first floor. What we established was that not only actually is this logistically much more preferable because it would be much harder to install cross-laminated timber when there's already a roof on the building, but the embodied carbon energy turned out to be considerably lower in this scheme. So this is how we got to this, and how we got to that point. I'm going to hand over to Dan to talk about the specific engineering elements of that.
Thanks so much, Charlie. Over to you, Dan.
Thanks, Charlie. So this was sort of a project where we're really looking at maximising what we could do with the existing historical building. So as Charlie mentioned, we've got a 25-year-old building. It's completely hemmed in on all sides, constrained on all sides. We can't do the usual approach of going up or down because, as Charlie mentioned, we've got the protected viewing corridors to some pools, so we can't go up. And then below, within the ground, we've got the scheduled monument, the old Londinium wall, and also numerous deep below ground tunnels. So that meant we couldn't touch the existing foundations, and we couldn't also touch the existing basement slabs. So what could we as a design team do to overcome these constraints? First of all, we looked closely at what we had already done. And what we found out is that 20 Giltspur Street was actually an incredible steel frame building with generous 5-metre floor-to-floor heights, first and second floor levels, with then very large plated girders spanning 21 metres over the Roman ruins below. This provided a huge column grid, which sort of maximised flexibility. And then coupled with that was a lightweight existing metal deck slab at all levels. So from the initial starting point of looking at a sort of light refurb to the existing building, an exciting opportunity emerged. From that, it then became possible, looking at to try and add in this extra massing by vertically relocating the existing first and second floors. As the project progressed and we got to tender, we ended up looking at 2 schemes running parallel. First, as Charlie mentioned, was looking at a CLT option, which is kind of a more traditional approach, whereby we would break out and remove the existing first and second floor slabs. We would then retain what primary steelwork we could and take out the other steelwork that we couldn't reuse. We'd then come back in, replace with new CLT panels and new secondary steelwork. But as this progressed, we started becoming more and more uneasy of demolishing what are perfectly good slabs just to replace them with something on an identical grid, and that just really didn't sit sort of right with the entire team, really. Because ultimately what it meant was that we'd end up having to sort of remove nearly 400 cubic metres of concrete from demolition, take out 160 tonnes of steelwork that we couldn't reuse, and also bring in over 1,000 cubic metres of CLT, which, as Charlie mentioned, we didn't have any sort of blue sky access, so trying to bring all that through existing apertures in the facade wasn't particularly easy. So the second option that we pursued from quite early doors, with sort of early engagement with jacking specialists, was this kind of wildcard option of trying to keep the existing first and second floors and jack them to new levels. As stage 3 progressed, we spoke to Deconstruct, who are now the enabling works contractor. And what came out of that was that this kind of wildcard jacking option gave an improved program, lower costs, less waste, and more reuse, which therefore meant a greater carbon saving. We were able to keep significant portions of the existing first and second floor metal decks. We were able to keep far more of the existing steelwork and minimise the amount of demolition. So we're minimising the amount of concrete that we need to take out of the building, and we're also then minimising the amount of new materials we have to bring back to site. So just as kind of a direct comparison between the CLT and the jacking options, we can see just looking at the kind of slab demolition drawings. With CLT, we had to remove everything, whereas with jacking, it's shown by kind of green areas, we're able to keep significantly more of the existing slabs. And then looking at kind of the demolition with the jacking within the kind of centre of the building, this really comes back to kind of the re-coring exercise that we've done, whereby the existing staircases have been brought back within the existing cores, and then relocating kind of the primary risers, which then has given us a much more efficient sort of floor plate and much more usable floor plate. So it's really sort of targeted demolition that's given us sort of the maximum benefit for the building. Then kind of looking at the principles of jacking, because we've got this huge existing steel structure, it was designed with very high imposed load capacities. So what it's meant is that jacking is actually quite efficient, whereby we can utilise that live load capacity from the floors above and in essence hang floors that we're going to move one at a time. So at each kind of column position, we're going to be installing temporary works and then pairs of jacks, which are then hanging the floor to be moved by divvy bars. The jacks are then positioned at each sort of primary beam to column position with a pair of jacks, and that gives us kind of ultimate flexibility to re-level the floors as we lift them up. And then once the floors are in their sort of desired position, we will then make good the existing beam to column connections. So why is all this important? Why are we going sort of all these efforts? So as we know, steel is everywhere, really. In 2021, we produced nearly 2,000 million tonnes of crude steel. And according to the World Steel Association, it's projected that we are going to continue to use even more steelwork in the future. This coupled with, as we all know, the increasing CO2 content in our atmosphere, how can we afford to continue consuming new raw materials at this rate? How can we kind of flatten these curves? So as we know, steel is one of the worst and most carbon intensive materials in construction, and globally it's responsible for approximately 10% of all CO2 emissions. According to the British Construction Steelwork Association, generally in the UK, we are actually pretty good at salvaging steelwork from demolition sites. But of that, around 86% is recycled, and only currently about 13% is reused. And whilst it's amazing to be able to recycle that steelwork, it does mean each time we do that, we've got to transport it from site, melt it back down, which is using energy to then make something new and bring it back. The kind of focus at the moment in the industry has really been trying to salvage steelwork from donor buildings, whereby we're demolishing one building, taking out the steelwork that we can salvage, sending that off to a salvager who then recertifies it, and then it goes back to a fabricator and then delivered to the new site. And again, whilst that is commendable, again, we're sort of double handling steelwork, and we're increasing road movements, so we need to do more. When we just look at how steel is produced, so in the UK, steel from blast furnaces produces around 2.5 tonnes of CO2 per tonne of raw steel. In the UK, we generally have an average mix where we get some of our steel from blast furnaces and some from electric arc furnaces. So in the UK, we average about 1.7 tonnes of CO2 per tonne of steel. Steel produced from electric arc furnaces is sort of an order of magnitude better, and that's where kind of all the new steelwork at 20 Giltspur Street is coming from. So that's around 0.5 tonne of CO2 per tonne of steel. ArcelorMittal are currently producing an electric arc furnace product called X-Carb, whereby it's still an electric arc furnace process, but they guarantee to use 100% of renewable energy to produce that steel. And then we come on to what is kind of the most promising way, and another order of magnitude better still, is using reclaimed steelwork and reuse steel, which is really minimizing that energy input. And that's really collectively as an industry where we need to be looking really hard from really early stages of what do our buildings have and how can we kind of best reuse what we've got rather than trying to bring new in straight away. So kind of summarising 20 Giltspur Street, really, we've managed to increase the GIA by around 30%. By that sort of targeted demolition and making the floor plates more efficient, we've managed to increase the net by over 40%. We are reusing and retaining in situ 80% of the existing steel structure. And then that's kind of led us to structurally our embodied carbon for this building, which, given we've got huge spans and really large pieces of steel, we're below 90 kilograms of embodied carbon per square metre of building, which, just to give a comparison, if we was to do this building using the more traditional sort of technique of demolishing and replacing with new, we would have been nearer 200 kilograms CO2. And then just kind of looking where we are on site, to say the job's on site progressing really well. We've kind of already undertaken our first phase of jacking, which was to lift 3 of the primary girders and raise them up within the existing metal deck slabs, just to gain a little bit of floor to ceiling height, just where we have pinch points under some of these large girders. And then likewise, thinking of other things, we've got a crane on the site, and that is currently supported virtually wholly off existing steelwork and new permanent steelwork, bar a few tiny props to brace up one bay. There's no temporary works associated with the ballasted crane. And then the final picture on the right is just looking at, as part of the jacking process, we're installing new perimeter steelwork, which the floor will be jacked to. So it kind of gives you a bit of a visual idea of the floor there is going to be lifted up to be level with that steelwork that you can see in the middle of the picture. And now I'll pass you on to Rachel and Simten.
Thanks,
Thanks,
Dan.
Thank you. I think one of the things that's clear from the presentation today is just what a challenging brief Simten issued to our design team. First of all, we wanted them to create as much additional space within this building, even though it had incredibly tight constraints, so we couldn't go higher. This building is within the St. Paul's viewing corridor, and we also have a section of the Roman wall, and as you heard, the mail rail tunnels beneath. I suppose the second main challenge we set for the team was sustainability, and I mean that in every sense of the word. You've already heard how we've chosen some low carbon, low energy M&E systems. Yes, that's a given. Yes, the scheme is going to achieve BREEAM outstanding. Yes, we've been monitoring the whole life cycle carbon right from the beginning. But what we have asked the team to do, and what we've pushed the team to do, is to keep questioning as we've gone through the design process about whether we can do things better. And I think that is what we've seen here in starting off with the CLT option. It was a known technology. It's obviously a low carbon option for the building, but in the background there was always this idea of jacking. But jacking's not something that happens every day. And so there was a risk that's associated with it. So we really did have to rely upon our teams, because how does it happen? How do we do it? And so ElliottWood really provided us with support. They provided us with examples. And at one point, George even promised that he would stand beneath the floors while they were being jacked to prove that it was going to work for us. I think the other thing that Dan mentioned was during the tendering phase, we were quite worried whether there would be enough enabling work contractors to actually provide us with a decent tender return. That's why we went out with the CLT option as our first option and the jacking option as an alternative. As we went through that process, we were given a lot of confidence by Deconstruct, and you've seen the work that they're doing on site at the moment. They took us to another building which had various listed elements, grade 1 and 2 listed, and they had jacked that building, and it looked amazing. You could see right through it. They have been really supportive with explaining the process, and they're so very committed to this that they have actually purchased the jacks. They think this is going to be something that they're going to be able to do in future, and why not? There have been incredible carbon savings here. We've also been able to, with all the design work that everyone's done, while we were looking and trying to reuse as much steel as possible, we were trying to reuse as much of the facade as possible. But when it has come down to it, by being able to retain those floors and lift them, that's how we've really been able to align the project with the circular economy principles. And we've also really reduced the impact of this scheme on our neighbours. So just in terms of that neighbourhood impact, this building is part of the Bank of America estate. It also has the St. Bart's Hospital adjacent, and the Holy Sepulchre Church next door. So by reducing the amount of waste that's produced, by reducing the amount of noise, By doing the right thing for the environment, we've also done the right thing for our neighbours. I think in terms of social impact and social value, we're really lucky for this building that it has such an incredible history of transformation. As you've heard, we've got some Roman ruins down in the basement. And during the original work that created the office building 25 years ago, there were quite a number of finds, archaeological finds. And as part of the work that we're doing, we're going to be providing an update of an exhibition, including some of those artifacts for the public to see. We've also been able to weave the history of the site into some of the design elements. So in terms of the planting that we're putting in the courtyard and also on the terraces, we have looked to the history of the site when it was part of the Greyfriars Monastery. And at that point, the area had a role in looking after the health and well-being of the local community. So in terms of the planting that we're proposing, we're looking at having medicinal planting throughout those areas. I think one of the other really lovely things that we have, and something that aligns with our direction to choose materials that have longevity, we've seen a number of items from Roman times. So we've identified some bowls and which are an amazing deep red colour, very similar to the brick that we're putting on the outside of this building. We also found some mixing bowls that would have been used to mix medicines, and they are actually the same stone that we're putting on the building here as well. So we are hoping that with this latest transformation, that it's going to have the longevity and of the other items that have been here on the site.
Amazing, thank you so much.
Yep, well, thank you all. So thank you, Rachel, Charlie, Dan and Rachel for presenting. We're now going to move into the Q&A section. So just to remind everybody watching and listening, feel free to type your questions into the Q&A chat box. I see we've got one in there already, which is fantastic. But yes, feel free to just put your questions to our panelist. You may wish to address a specific person and type their name, or Rachel will do an expert job, I'm sure, of kind of filtering those to the right person as we get going. But just to start, I was going to pick up on something you said at the end, Rachel, around that sort of culture of questioning, like how can we do better, and sort of challenging the team to kind of keep that in their minds all the time. So I wondered if, like, BGY together, Charlie, Rachel, and then Dan as ElliottWood, and Rachel, even you as Simten, could say, how do you do that culturally within a practice as well as on this project? That how can we do better? Who wants to go first?
I think this is something that we've talked about quite a lot, isn't it? The fact that there has been a sort of historic culture of architects wanting something and structural engineers making it happen. And I think this has been much more of a process of us both all questioning one another and sort of pushing one another and asking difficult questions. And I think it's quite interesting how some of the ideas around jacking sort of came up in your office from having, it sounded like, quite open and honest debates, and really thinking a bit more broad sort of scale about the context of what we're doing and like why we're doing it. So I don't know if you want to touch on that a little bit, Dan, in terms of like how that internal conversation happened.
Yeah, I mean, certainly from our side, myself and my colleague George ran a very high level conversation talking about two other jacking projects. One was Macy's Rising Factory and another was Kojima's demolition and cut down method, which both kind of employ jacking principles. And it was really drawing inspiration from other projects and things around us and seeing how we can kind of relate those to our projects. And then obviously come kind of a client who would agree with the kind of left field idea.
And I think it was that running the two schemes in parallel to de-risk it was really important as well, and like having a team that was committed to it. So I remember coming along to meetings and going, hold on, this is really exciting. It was important for us to get behind it, I think, in order to sort of go, no, we want to do it too. We're on board with this. You're on board with it. So that Simten could then sort of understand that the whole team, was on the same page a little bit about the fact that it could be a really good option. I don't know if that's how it came across to you, Rachel.
It did. I suppose I came to the scheme quite late, and so my first question on hearing about jacking was, oh my God, how do we do that? And I think having the team explain it, and also the commitment to actually the focus on sustainability and the focus on improving the carbon credentials of the scheme. It was by far and away the most successful thing that we could do. And I think we all worked together to really see how to bring that into fruition. And it was a lot of work. The decision was made, I suppose, as you said, we were running 2 schemes at the same time. So maybe it was a decision that was made a little bit later than you would generally like to, but it was the right decision for the scheme because it saved on program, it saved on cost, and as I was saying, also just that general impact on the neighbours as well. It was all positives.
I think as well that engagement with Deconstruct was super important. They were a really critical part of making this happen, and I think from their perspective, being able to do this is a really good thing to add to their portfolio of what they can deliver. So they saw a real business opportunity in perfecting this as well.
Amazing. Well, I think, Rachel, if we move on to the questions that are in the channel.
So yeah, there's one on, is jacking used much elsewhere? And you mentioned a few precedents. I don't know if you wanted to touch a bit more on if how much it's used at the minute in the industry, but also, Charlie, I know we were having a discussion about what the potential for this is and what sorts of buildings we think it might become useful on. So I don't know if Dan, you want to go first?
Yes, I think in the industry, jacking is used quite extensively, generally for lifting things, be it on sort of bridges, things like that. Let's say Macy's Rising Factory in Stratford was a huge one where basically they were building and finishing it all within a formwork that was being jacked as the building extended. What we can't find is actually using the principle to move elements of a building within a building. So I think that's kind of where it's quite new and innovative.
Yeah, what do you think, Charlie, in terms of the potential for additional use elsewhere?
Well, I think it's just demonstrating by this building. It's more a case, I think, buildings are designed for the moment they exist in. And such as, I think very sort of clear in this building, as I mentioned, this building was designed with trading floors in mind, which had very high ceilings, which allows you to do that. And I think it feeds into the same principle of you might take a building and assume you can't do something, but actually if you think, well, why was it built in a certain way? And you realise actually that way is now redundant. And then something like jacking comes in. I mean, obviously it does depend on the actual structure and various things like that. But I think it may be a building that is not relevant now in 10 years' time because its use has changed, will become part of it. But I think it's definitely something which we apply any time really, where there is an opportunity for a building and its use is no longer used anymore, and you upgrade it that way.
And we were doing a bit of research on trading floors and why they were designed in that way. And trading floors used to be designed with really high floor to ceiling heights, but I think that was mostly to do with the fact that they had big screens up at high level, but also really, really high cooling loads because of all of the CPUs and the computers, meaning that you had that stratification of air. Now we have much more efficient systems that have much lower cooling loads. The cooling that we're doing is more efficient, so you don't need that stratification of space. So those sort of like 90s, noughties buildings are kind of, you would imagine that there's maybe a pool of them that are coming up. We've got another question which is about the windows and the driver for changing them. Were they installed because of the additional floors, or was it more to improve the operational energy? What were the drivers?
Well, it's a bit of both. Obviously, the age of the building means to some extent the windows themselves were probably coming to the end of their design life anyway. Obviously, great to be able to refurbish them, but with the jacking, it would have meant that the windows are no longer the right size. But also we need to ensure we want to try and again introduce the more holistic opening elements to the windows, which were not so available in the previous existing building. So that allowing the building to actually function more efficiently. So yes, you know, like in all these situations, and from an embodied point of view, you won't want, the best thing is not doing it. But when you've got a situation where these windows would needed to have been refurbished in some shape or form anyway, and then also, but if you just left them in place, they wouldn't have been as efficient. They wouldn't have been able to allow the flexibility, and we were doing the jacking, which was going to save all this carbon. That's why we had to come with the window and change.
And those interfaces with the internal wall insulation and making sure that they were openable as well was all sort of part of it. There's a question I wanted to ask you, Rachel, which is we're having a lot of discussion on our projects about Cat A. Because we know that there's often a lot of waste that occurs when we install a speculative Cat A, but then a tenant comes in and they have different requirements and then they end up taking lots out. But we often find that it's a difficult discussion with clients because the expectation in the market is that you will install a Cat A. I don't know if you could touch a bit on like how that discussion happened internally and how you came to the conclusion.
I think it really depends on the building. I think what we're looking at now more and more is that we would maybe just install maybe a floor or a smaller area of the building with Cat A, because it does just seem really wrong that you should spend all of that money and then it does just get removed. But I think it also just depends on the kind of market that you are building in. There are obviously some smaller buildings in different locations where the kind of tenant that is going in may not be as sophisticated as a tenant that's going into the city. So they would want fitted space or maybe even some of them would be looking at fully fitted, but it really does depend on the building and the kind of tenant you're trying to address. But certainly we don't want to be putting in anything that's then just going to be ripped out. That's absolutely not what we're wanting to provide.
Yeah, I think it's definitely a good part of that overall discussion.
I think the advice we have in this place is that the Cat A has been designed. So it's not just a case of saying to a tenant, there you go, there's your empty space and just go work. They've already got the template for them to go ahead and build it. Now, a sophisticated tenant would be able to maybe change that template. A less sophisticated tenant may actually say, well, actually, could you put it in? But you know, that would mean that we could work with them at the same time as their own fit out. I think it just gives that flexibility. But if you don't have any design for it, that's where I think the worry is. So I think everything is set up already for someone to come in. And actually, as you said, why would you actually put it in when actually it's purely someone to take it out again?
Yeah, absolutely.
Great. Well, thank you so much. The presentation was fantastic. Compliments have come into the chat box there. So compliments to all of you from the audience and from us at the Building Centre and for taking the time today. It's just great to hear a client and a design team presentation looking at innovation in retrofit projects. So we have recorded this so we can share it with our audience and share it with you all as speakers today. So you can kind of keep reviewing it and send it on to people. Yeah, so thank you for speaking and thank you everyone for attending. We have more webinars running up through the rest of June and into July, and we've got some in-person events as well, one tomorrow evening in the Building Centre, and we've got a colleague of Rachel and Charlie's speaking on that commercial panel event. So if you can make it into Store Street, just up from Tottenham Court Road, come and see us and join that event tomorrow. There's some drinks and networking as well. If not, if you can't come to us in person, do check out the YouTube channel for the recordings, do book online for future events, and we'll hope to see you again shortly. So bye to speakers and bye to everyone who's attended today. Take care. Bye.